Hey guys, it's Mr. Sarley. Welcome to your YouTube homework review. I am on my planning day, and you guys are taking the midterm today. And as I'm looking at the midterm, I know there were some questions that involved integers and dividing by fractions. And I'm sure for some of you, that was kind of something you forgot from 6th grade. This week's homework packet is going to go over those types of problems as well as build up to the harder test ones. So definitely check this out and we'll see how you do. Okay, so there are a lot of ways to divide fractions, but the main one that you guys learned in 6th grade was keep, change, flip. So in this first division problem, I'm going to keep 3/4 the same. I'm going to change division into multiplication, and I'm going to flip the 2/3. Basically, I'm going to turn it into the inverse. So I'm going to do 3/4 times, and then I take the inverse of 2/3, which is 3/2. And I do that because multiplying fractions is super easy. To multiply fractions, all you need to do is multiply across. So the numerators, 3 times 3 is 9. And then the denominators, 4 times 2 is 8. From there, I'd probably simplify it a little bit because 8 goes into 9 once, and you'd be left with 1/8 left over. For B, again, we have a division of fractions problem. So I'm going to do keep, change, flip to change it into a multiplication problem. Then multiplying the numerators, I'm going to get 15. Multiplying the denominators, I'm going to get 6. And then if I wanted to simplify that, 6 goes into 15 twice, because 6 times 2 is 12. And then 15 is 3 more than 12, so that would leave me with 3/6 left over. Then take a look at C. C is already a multiplication of fraction problem, so all I need to do is multiply across. 3 times 2 is 6. 5 times 3 is 15. And I'm pretty much done, except I see that both 6 and 15 can be simplified by a factor of 3. So I'm going to divide by 3/3. 6 divided by 3 is 2. 15 divided by 3 is 5. Then for D, this is a division problem. It's just written in fraction form. So this line right here, again, means division. So basically, this is telling us to do this problem. The numerator divided by the denominator. Then I'm going to do keep, change, flip. So 2/3 times 8/5. And then I could multiply across. 2 times 8 is 16. 3 times 5 is 15. And as a mixed number, that's one whole, because 15 out of 15 is a whole, with 1/15 left over. All right, moving on to the silver level. For this one, I'm reminding you guys of the song. Same sign, they multiply to positive. Different signs, I'm getting it, it's negative. So it's going to be the same idea here. We're multiplying and dividing, but we got to pay attention to if our answer is going to be positive or negative. This first problem has a negative divided by a negative, so I know my answer is actually going to be positive. So from there, I'm going to do keep, change, flip. So we got -1/2 times -4/3, because I'm taking the inverse of -3/4. Then I multiply across. I got 1 times 4 is 4. 2 times 3 is 6. And again, since both of the fractions were negative, our quotient is going to be positive. And then from there, I see that 4 and 6 both have 2 as a factor. So I'm going to simplify this to get my final answer of 2/3. For F, I'm going to rewrite this problem thinking of this as division, and I'm going to take the numerator divided by the denominator, which is negative, so I keep the negative sign. You could even put in parentheses because it's negative. Then I'm going to do keep, change, flip, and I'm taking the inverse of -4/5, so I get -5/4. Now I multiply across. 1 times 5 is 5, 3 times 4 is 12, but pay attention, this is a positive, this one's a negative, and if you multiply two numbers with different signs, the product is going to be a negative. All right, for G, I'm trying to find the product of two fractions. Since they're both negative, they have the same sign, I know my answer is going to be a positive. So I'm going to keep that in mind, and then I just multiply across. 3 times 4 is 12. 7 times 5 is 35. And I keep the answer positive because the factors were both negative. And then I actually can't simplify that because you can't find a common factor of 12 and 35 except for 1. I hope these problems are getting easier and easier for you. If at first you were a little confused, they're really not too tricky. However, H might be a little tricky because we don't really have fractions. We have a whole number divided by a mixed number. Conceptually, what you're trying to figure out is how many 1 1/4 go into 15. So you could kind of keep adding 1 1/4 over and over again until you get to 15. But you can also use keep, change, flip. You just have to get this set up first. First, I'm going to think of 15 as 15 over 1. Then I need to write this as an improper fraction. Because some people think if you want to do keep, change, flip, you can just rewrite 1 1/4 and as 1 and 4 over 1. The problem is this whole number. It's hard to take the inverse of a whole number, so we actually can't do it that way. What we have to do first is we just have to rewrite the mixed number as an improper fraction. And 1 1/4 is the same as 1, 2, 3, 4, 5/4. So I rewrite this like that first. Now I can do keep, change, flip. So 15 wholes, and now I change division to multiplication, and I take the inverse of 5/4. Now I can multiply across. 15 times 4 is 60. 1 times 5 is 5. And to simplify that, I can just figure out how many 5's go into 60. And if you were to do that division, you should end up getting 12. And that's why the answer to this one is 12. If you've been following the video, I really hope you'll pause it now and try this last one on your own. This is what a state test level integer problem can look like. But I'm going to go over it here just to see how you did. So this problem has something inside the parentheses. So it's basically anytime you have an expression with more than one thing to do, you always follow the order of operations. And the first step in order of operations is you do anything that's inside of parentheses, which is this. So basically the first thing we got to do is 2/3 minus 5/6. And most of you will remember we can't subtract fractions unless the denominators are the same. So you need to take these denominators and make them the same. I think I'm just going to turn them both into 6 because I see that 3 goes into 6. So I'm going to multiply this fraction by 2 over 2. And now I have 4/6 minus 5/6. To solve that, I'm like, all right, I'm taking a small fraction subtracted by a big one. That makes me think of my integer unit, and I'm going to use a number line just to be sure. So I have 4/6, and I'm subtracting 5, but it looks like we're going to stop at the friendly number 0, because we're going to end up going past it. So I'm going to subtract 4/6, and that would mean I have 1/6 left over. So then I have -1/6. We're not done. That's just this first part. We know that this is the same as -1/6. So I'm going to make us a little bit of space here. And now I'm going to rewrite the problem as -1/6. And then the rest of the problem has this big division sign and then 3/4. Now it's just like these other problems that we've been doing. I have -1/6 divided by 3/4. And then I'm going to use keep, change, flip. So keep, change, flip. I'm going to multiply across. 1 times 4 is 4. 6 times 3 is 18. And then I'm going to be really careful because I'm multiplying with one negative factor and one positive factor. Different signs is going to be a negative. And then I come check over here, and I'm like, wait a second, my answer is not here. Well, I know it can't be C or D because my answer needs to be a negative. But then I think, wait a second, I can simplify this. I can divide it by 2/2. And -4 divided by 2 is -2. 18 divided by 2 is 9. Oh, wait a second. That is answer A. All right. My secret word is going to be auditorium because that's where I've been hiding to do this video because everywhere else is really loud. I'll see you for part B in a hot minute.